Okay, our next section is going to be 312, which is vector subtraction. So what we saw earlier was vector addition, and it was that tip to tail method. We are going to use that very same method, but there's one little thing that we have to do in order to kind of switch over from addition to subtraction. And that is going to be when we subtract a vector, we're simply going to reverse its direction 180 degrees, and then we're going to add it just like we did tip to tail when we did vector additions. So if we look at, for instance, an equation, we want to find a resultant, and we're going to take vector A minus vector B. What we're going to do is just like in algebra, instead of saying minus B, we can say we're going to add the negative B direction. And to add the negative B direction, we're simply going to take that positive vector and change it 180 degrees. So to do that, very, very simple. If we have the positive direction of a vector, so A going up and to the right, positive, to switch its direction, we're just going to put the arrowhead in the opposite side of that vector. Okay, so what we would do is we would change the direction and then we would simply add the negative. Okay, so we are going to look to example 310 to kind of go through this process. I'm going to slightly change from the book. So we're just going to kind of go with, there's two methods that you can do this in. The book shows it in one. I like staying consistent with adding tip to tail. So we're going to kind of do this one. We'll end up with the same answer, but we're going to approach it just slightly different than the book does. So at the bottom of page 55, we are going to find the problem statement for example 310. And it says we want to graphically determine the result of subtracting the velocity of B from A. So the equation that we have here, instead of R, the resultant they're identifying as J. So J is going to be equal to A minus vectorially B. Okay, A minus vectorially B. Now, what we're going to do is we're going to rewrite it just like we saw earlier. So we're going to say J is going to be equal to A plus vectorially, in parentheses, the negative direction of B. Okay, the negative direction of B. So what we're going to do is when we look at B, its positive direction right now is going down and to the left at that angle. What we're going to do is we're going to show it going up and to the right, and we're going to rename this negative B. Okay, and then we're going to add it tip to tail just like we did in the past. So let's go over to AutoCAD and go through this process. So we're going to do just like we did before. We're going to start with our start file, and we're going to draw each one of these vectors. So A is 32 units going up and to the right, slightly up and to the right, and it's 9 degrees less than 180 degrees, right? So back over here, I'm going to draw A, take off my ortho, and it's going to be at 32 tab and 180 minus 9 degrees. What would that be? What would that angle be from 0? 170, 171. Okay. There we go. Okay. So that's going to be my first vector. I'm going to put the arrowhead going up and to the left. Okay. And then I'm going to move my A right about there. And then I'm going to scale it. It does need to be bigger till it's maybe about that big. Okay, so that's my A. Now I'm going to put B in position. Okay, so right now, B, the positive B is going down and to the left. So from 0 degrees, right, this would be 180 plus 60, okay? And that would be 240, right? So I'm going to draw this with the line at 240. Does that make sense? Wait, no, 246, right? 246, is that right? 180 plus 66 is 246. Somebody check my math with a calculator. Is it 246? Nope, use a calculator. 180 plus 66. 246. Okay, excellent. That's okay. Oh, okay, that's okay. That's all right. So we're going to draw that line at the 246 so that we have it. So it's going to be this line and it's going to be at 56 tab 246. Okay, so that's the direction of my line, right? Instead of showing the arrow going down and to the left, we're going to show the arrow going up and to the right. Okay. And we're going to label this negative B. So I'm going to say copy my A because I scaled that one already. And I have to put the negative out front because we switched the direction. This is negative B. Yes.
I need the symbol, the arrow symbol too, like, and
For what? For the equation?
no, like, oh, it labeled it as negative.
No, because we have it next to the vector. So you don't need a vector label. Is that what you're asking?
Yeah, like if you look at the book, it's still on.
That's in the vector equation. This is just labeling the vector itself. So you just need to have it as negative B. Is that helpful? Is that okay? Okay. So now let's write the equation. So we're going to do a copy. And I'm just going to use my A here. And I'm just going to say, okay, the equation is going to be J is equal to, and I think this is what you're asking. It's going to be A, but now we're going to do this plus the negative B, okay? So we're going to do plus greater than symbol because it's a vector addition. And we are going to add, so put parentheses, the negative B. Okay, does that make sense to everybody? All right, oopsie. Parentheses. So by doing this, we're still doing in vector addition because it's going to be tip to tail, but now the new label for this vector of B is negative B because we switched the direction 180 degrees. Okay, it's really like just like an algebra quantity. We're adding the negative version of it, right? Okay. All right, so now we're going to do our equation. So because we know everything about A and B, we're going to start on that right-hand side. So A is the first quantity, so we're going to put our origin at the tail of A. So I'm going to do a horizontal line, vertical line showing, oopsie, showing that origin large enough so that when we do our screenshot, we can see it. If it's too small and I can't see it, then points off, okay? And now we're going to add the negative B. So the negative B is already drawn in its negative orientation. We're simply going to move that vector. Its tail is going to go to the tip of A. So it's going to go up and to the right. Does that make sense? Okay, and it's still labeled negative B. Okay, its positive would be down and to the left. All right, so now we're going to put in our resultant, which is J. So this time we're going to be on a new layer, and we're going to go from the origin to the endpoint of that last vector. And then I'm going to just kind of exaggerate my arrowhead here so that it's longer so we can see, because that's our final answer. We're going to label this J. Labels could be a little bit bigger, but I'll leave it at that. Make my equation so it's by the diagram. And then now on my notes layer, we're going to add an align dimension for the length or the magnitude of J. Okay. Too small, right? So I'm going to have to go to annotate or down arrow by dimension, modify, and on the fit tab, I don't know, I'm going to do 20 to start. See if that looks good. Oh, that's pretty big comparatively, but so I'll go back. We'll do modify. It does not have to be perfect. I'm going to do 12. Okay, set current and close. That's about right. There we go. So that's how many units. It's 56.8. Yep, and that's what they've got. And then I need to do my angle. So my angle, go back to my home tab. My angle dimension is going to go from the horizontal to the angle. So it looks like it's 99. I'm going to kind of pull it out in a way. How does that look? Now, if I would do a screenshot, I feel like my J, my A, my B, and my equation are going to be kind of small. So I'm going to scale those each. Start at my origin, and I'm going to, oops, thought I did scale. I'm going to scale each one of those. I'm going to say 1.5. And I'm going to have to move them back closer. That's definitely better. This is B. And then make sure the negative is in front of the B, and then it's being shown up and to the right. Okay. So here is your final result. If we compare that with what is in the book, you're going to notice we ended up, oopsie, with the very same answer. So the length of it is 56.8, and it's at a 99-degree angle from 0. Now, you're going to notice something different about their example, and this is where we differ. I'm going to wait till everybody is looking up here. Okay, this is just an important distinction, because if you look back in the book and you want to follow along, you're going to notice they did their problem different than we did, okay? So they started with their origin here. They put A in place, which is their first vector here. But notice they did not add the negative B. They subtracted the positive B. So they kept the B going down and to the left, and they're showing, if you would, the two arrowheads tip to tip. That's another way of doing it. But then you have to go back to the origin with J and put J to the tail. I like keeping things consistent. If we do it the way we did, now I'm not saying it's better, but you don't have to remember to do tip to tip and tip to tail, okay? Because it's subtraction. All you have to do is you just change the direction of your B to be on the opposite side, and we add tip to tail this new negative version. And then putting the resultant in place, it's the same, where we start the tail at the origin and the tip still goes to the tip of the last vector, even though it's a negative value. Does that make sense? I like this better because it's more consistent with adding. So you don't have to learn a whole new set of rules, if you would, okay? So that is the difference between us and the book. The book presents both methods. I just use this one because to me, it's just easier to transition from what we already know for adding to subtracting. And all we have to do is one thing different, changing the direction to be 180 degrees different, and then adding a tip to tail. Okay? So that's our example for subtraction. We have another example for subtraction, I believe. If we go back here, we should have example 311. So our next example 311, you're going to notice, is at the bottom of that same page 56. And this time we have 1, 2, 3, 4 vectors, okay? If we look at the vector equation here, it's going to be A minus B minus C plus D, okay? So first things first, we're going to get into doing this one, but we are going to first draw the vectors in their positive direction, okay? And then we'll deal with the negatives when we set up our equation. So I'm going to go underneath AutoCAD here. I'm going to reopen my start file, okay? And then I'm going to save as example 311. Okay. And then what I'm gonna do is just simply draw each one of these. In this case, they go from 200 to 300, so they're gonna be pretty big in relationship to our text, but that's okay. So I'm gonna start with A. Just a little bit larger. Now I'm again going to start drawing first in their positive direction, and then I'll change once we do our vector equation, anything that's negative. Right. Looks like everybody's pretty close to having these in place, right? Okay. Once you have all four vectors in their positive drawn direction as identified in the problem, okay? what we're going to do now is we're going to look at our vector equation. So as they have it stated, they want us to find the resultant J using A minus vectorially B minus vectorially C plus vectorially D. Okay. I'm just going to wait. Does everybody have their vectors in place? Okay. All right. Everybody said, okay, because this is something I want to make sure we all understand about rewriting this in the right orientation. So I'll wait till I have everybody's attention and eyes. Okay. All right. Okay. So now this is how we would do it if we would do kind of that tip to tip or tip to tail type of a thing. Okay. Where you have to remember the different rules for subtraction than addition. I like to make this into an addition problem. Okay. So anytime I see a negative, I'm going to rewrite this. J is equal to A plus vectorially the negative B. Okay. And then where I see the next negative plus vectorially the negative C. And then we would finish with the plus D. So we have positive or additions, pluses for each one of our vectors. And then we just change the direction of these two vectors right here to be 180 degrees from their positive direction. So now what we're going to do is we're going to go to B and C, and we're going to change them to their negative equivalent. So if we go over here, right now, this is the positive B. Okay, so all I'm going to do is I'm going to erase my arrowheads and I'm going to draw them 180 degrees from where they were at and then relabel this as the negative B. Okay, so now it's going down and to the left. That's the negative B. The same for C. The positive C is going down and to the right. I'm going to erase those arrowheads. I'm going to put them up and to the left. And I need to rename this negative C. Okay. So I've got positive A, negative B, negative C, and a positive D. Okay. Now I'm going to put in my equation. So I kind of started it down here. J is equal to A plus vectorially, whoopsie, greater than sign, and then parentheses negative B, and then plus vectorially negative C, and then plus vectorially D, whoopsie, D, okay? So now we're going to do tip to tail and everything after we've changed the directions to be their negative equivalent for B and C. Okay. All right. And then now we do it exactly the way we did before. So if we look at where our origin is, our first vector is going to be A. So that means that A is going to have the origin at its tail. So I need to add the origin at the tail of A. I'm going to make it a little bit bigger. Origin. Okay. Now, according to our equation here, I'm going to add the negative B. So B is in its negative orientation. I'm simply going to move this. Its tail is going to go to the tip of A. And of course, I made that a little too. My origin a little long. So I will put that up nearest so it's not in the way. Okay. Then I'm going to add the negative C. So I'm simply going to move the negative C, the tail at the tip of B. I'm going to change this to be to the outside. And I'm going to make this a little bit shorter so that my origin is not interfering. There we go. And then I'm going to add D. So I'm going to move D, tail of D, to the tip of C. Okay. all I have left is to go to the opposite side of my equal sign. So I'm going to switch to my object 2. I'm going to draw a line from the origin to the tip of the last tail, or the tip of the last vector. And my tail of this vector is going to be at the origin, and its arrowhead is going to be at the end of D. So I'm going to kind of put this in here, and I'm going to move D. Then I'm going to copy one of my letters because this is my resultant. So I want to label that as resultant. Okay. And then I'm going to change to my notes layer. I'm going to put an aligned dimension for the length of my resultant, which I cannot see, right? Garrett. Oh, I'm so sorry. I didn't mean, you know what? Out of habit, I put R. It should be J. Thank you for recognizing that. J, nope. Whatever your resultant variable is, make sure you use that in your equation. I go to R right away all the time because in statics, we call it R all the time. We don't change it. All right, so now I want to go to my annotate tab, arrow down, go to my modify, fit tab, and I don't know, was it 100 last? 80? 80, yep, we'll start with 80. I think that's a good place to start. Modify, whoopsie, cancel, set as current, okay. That's pretty good. Yeah, I'll see that. I'm gonna put my equation here, so, well, maybe I won't. The letters are smaller. That's okay. That's all right. So there's my length. I'm probably going to pull it out further so that it's easier to kind of see how long that is. And then I need to add my angle. So I'm going to go back over here, do an angle dimension from the horizontal to my resultant, put it out a little further. And I'm getting 81. So let's look what we have for the answer on page 57. Looks like we have 365 is the magnitude, and we've got 81 for the angle, which I know that we got. So 365 as well for our magnitude on our CAD. So this would be the screenshot with the equation, variables, and your magnitude and directions. Make sure you put arrowheads on all of your vectors because they're not lines, they are vectors. And you should be ready to hand that in as part of your practice problems. Any questions on example 311? Okay. Oh, yeah. No? Do you have a question?
It gives you the equation first.
Yeah. Yep.
Negative vector, negative vector.
Right, right.
So then we say to ourselves, oh, we want to.
That's why, yep. So that's why when I was underneath here, this was how they did it. So they did it as a vector subtraction. And if you look at how they did theirs, they did like the tip to tip and all that kind of stuff. Okay. But as I had stated, an alternative method is to still stick with adding your vectors tip to tail like we normally do, but anything that was a subtraction, changing those to adding as a negative version of. So that's when we change the direction of B 180 degrees and the direction of C and labeled them in their negative orientation. So notice we don't leave this as a positive B and a positive C. We're adding still tip to tail, we're adding the negative version. So we want to make sure that we write our equation to reflect the process that we took. Is that helpful? Yeah. So in this case, we wouldn't want to put the way that the book did it. We rewrote it so we could apply the same addition rules. So adding the negatives instead of subtracting the vectors. I do too. I do too. Yeah. I feel like it's just more consistent process-wise and rules-wise, where it's only one thing that you have to do different to make something negative, as opposed to remembering tip to tip and tip to tail, and am I positive, am I negative, that kind of thing. Okay. All right. If there aren't any questions, then I am going to stop our recording here.